So here is another question on solving quadratic equations through completing the square method. So here the quadratic equation is 2x square plus x minus 4 is equal to 0. So we will try to solve it. So first we'll write the equation 2x square plus x minus 4 is equal to 0. Again, here also you'll see, if we try to do a plus b whole square, a minus b whole square thing here, it is not in a perfect square form. Okay, so in order to convert it into a perfect square, we'll multiply 2 on both sides, then it will become 4x square, so it will become 2x whole square, that's why. So we'll multiply 2 on both sides. Okay, so then we get 4x square plus 2x minus 8 is equal to 0. Yes. Now what we'll do, we'll take this minus 8 to the right hand side. Then it will become 4x square plus 2x is equal to 8. Okay. So now we have to convert this 4x square plus 2x in a plus b whole square form. That implies 2x whole square for 4x square, 2x whole square. That's why we multiplied 2. So 4x square we can write it as 2x whole square plus this 2x we have to write it in the form of 2ab. So a is 2x. So 2 into 2x, we need to multiply a number here such that this result will be equal to 2x. So simply 1 by 2. 2 will get cancelled and we'll have 2x. So b is equal to 1 by 2. Then we have to add plus b square to convert it into a plus b whole square form. So 1 by 2 whole square, and also we have to add 1 by 2 whole square on the right hand side to balance it. Okay, so here this is a square, this is 2ab and this is b square. So a plus b whole square. Now we can write it as 2x plus 1 by 2 whole square, which is equal to 8 plus 1 by 4, which is equal to 32 plus 1 by 4, equal to 33 by 4. That implies 2x plus 1 by 2 is equal to root over of 33 by 4, which is equal to plus minus root over of 33 by 2. Okay, so that implies two x is equal to minus 1 by 2 plus minus root over of 33 by 2, which is equal to minus 1 plus minus root over of 33 by 2. This. Now that implies x is equal to minus 1 plus minus root over of 33 by 4. So the two values of x here are x can be equal to minus 1 minus root over of 33 by 4, or x can be equal to minus 1 plus root over of 33 by 4. Okay, so these are the two values. Okay, so same approach. So what we did, again, to convert it into perfect square form, the original equation was 2x square plus x minus 4. We multiplied 2 on both sides to convert this 2x square into 4x square, perfect square form. So then we converted this middle term, this 2x term, into 2ab format. We multiplied a certain value of b, then b square on b square added on both sides, then a plus b whole square format. We converted this entire 4x square plus 2x form, and then we solved for the value of x. Okay, so this is the. So here is another question on solving quadratic equations through completing the square method. So here the quadratic equation is given by 4x square plus 3x plus 5 is equal to 0. So we have the quadratic equation 4x square plus 3x plus 5 is equal to 0. So now there is no need to multiply anything, it is already in perfect square form, this ax square thing. Okay, so directly we'll go for the solving part. So what we'll do, first we'll take this plus 5 part to the right hand side, so it will become 4x square plus 3x is equal to minus 5. Okay, that implies, then we'll convert this 4x square plus 3x part into a plus b whole square. So 2x whole square plus 2 into 2x. Now we have to multiply b here to convert this into 2ab format such that 2ab is equal to 3x. So we have to multiply b here such that this result will be equal to 3x. So in order to do that, so let's see here. Let's say 2 into 2x into b is equal to 3x. That implies b is equal to how much? 3x by 6x. Sorry, 3x by 4x. So it will be 3 by 4. So b should be equal to 3 by 4. By 4. Okay, so 2 into 2x, so 4 gets cancelled, so this becomes 3x. Okay, now we have to add 3 by 4 whole square to convert it into a plus b whole square format. Now on the right hand side also we have to add it to balance it, 3 by 4 whole square. Now this is equal to 2x plus 3 by 4 whole square. Okay, 2x plus 3 by 4 whole square, a plus b whole square. So here this is a square, this is 2, this is a, this is b plus b square. Now this is equal to 2x plus 3 by 4 whole square is equal to minus 5 plus 9 by 16, which is equal to minus 80 plus 9 by 16, which is equal to minus 71 by 16. Now here is a very interesting situation. Here the square of something is coming in negative form. See here. 2x plus 3 by 4 whole square, it is equal to minus 71 by 16. Negative. Square of something, it is coming negative. Now this situation is impossible when we are considering real numbers. Okay, but the solution is possible, okay, for real numbers. This is not possible, but the possibility arises for another concept which is called as complex numbers. But we have not discussed complex numbers, so we'll not go into that direction. There is a separate chapter in complex numbers where complex quadratic equations are dealt with. So we will keep it to for that. Okay, now here we will say that as the square of this is negative, so it does not have, the above quadratic equation does not have real roots. Real roots or real solutions do not exist for the quadratic equation, but complex roots exist. So that is when we go into the domain of complex numbers. So that is a different thing. So let's not go into that here. First we'll discuss complex numbers separately, and then there we have a separate chapter which is complex quadratic equation. This is for real numbers. So if you remember the definition when we started with quadratic equation, ax square plus bx plus c is equal to 0, where a, b and c are real numbers and a should not be equal to 0. So we are concerned only with real roots, real solutions, real numbers here. When we go and discuss complex numbers in the future in separate videos, there we have a separate chapter which is complex quadratic equation. There we'll discuss that. Okay, so for this there are no real roots or real solutions for the given quadratic equation. Okay.